Hi ladies, I just wanted to talk you through part D of our 2015 question on benzoic acid. So it is a percentage yield question. So it's one that we were that I did a little example of the other day, and it's also related to the experiment that we did last week. Now there's one tricky thing in this question, which is that they don't give you the mass of your phenylmethanol to work out the moles, they give you the volume. But they also give you the density, and from your volume and your density, you should know that from junior cert, we should be able to work out our mass. Okay, so I'm going to show you quickly how to do that. Alright, now for this experiment you are going to need two different triangles, your mass density volume triangle and your mass moles and AOR and MR triangle that we know very well. Okay, now to work out your mass of phenylmethanol, it's going to be cover over mass on this, our density by our volume. So it's going to be very simply going to be our 1.04, which are given in the question, which is your density, multiplied by your 2.7 centimeters cubed, which gives you 2.808 grams. That is our mass of our phenylmethanol. That's the mass of our starting material. Now, to work out your moles, because we always have to work through moles when we're doing percentage yields, okay? Again, we have to use this triangle. Our mass divided by our molecular weight of our phenylmethanol. So our mass, now we've worked that out, is 2.808 grams. And our molecular weight is something you're going to have to calculate yourselves. So you draw out your phenylmethanol from your question. The only thing that they haven't given you here is these hidden hydrogens here in the benzene, so you have to count those up. So you work out that phenylmethanol is C7H8O. That's your formula for phenylmethanol. So when you add all those up, you get a molecular weight of 108. So to work out your moles, it's going to be your 2.808 grams divided by your 108, which is your mass of your phenylmethanol, and that is your 0.026 moles of phenylmethanol. Now it tells us in the question that phenylmethanol is our limiting reagent. That is what's going to determine how much product is made. And it also tells us in the question that it's a 1-to-1 reaction. One phenylmethanol gives us one benzoic acid. Okay, so if you have one phenylmethanol, okay, that means if you've got 0.026 moles of this, you're going to get 0.026 moles of your benzoic acid. Okay, so what we can do now is, if we've got that number of moles of benzoic acid, this will be our theoretical yield. If we calculate that, if we convert this into grams, that will be our theoretical yield of benzoic acid. So if everything goes perfectly well in this reaction and it isn't reversible, this will be our theoretical yield. So let's have a little look at that now. So there is our benzoic acid here. So we're going to have to, again, we're going to be using our triangle again. So we're going to have to work out our molecular weight of our benzoic acid. So again, you have to put in your hidden hydrogens here. So it's C7H6O2 this time. Therefore, our molecular weight is 122. Now, excuse me, this is rubbed off slightly. So 0.026. So we now multiply our 0.026 moles by 122 to get the mass of our benzoic acid that we can theoretically produce if everything goes perfectly well. So that is 3.172 grams of product that we can produce. That is our theoretical yield, okay, the best yield possible. But we were told we only got 1.83 grams of our product. Okay, that's our actual yield. So our percentage yield is done just like a test result. So if your test result is 1.83 and your total test is 3.172, you divide them by each other, multiply by 100. So therefore, our total percentage yield, or actual percentage yield, is the following: 57.69% or 58%, because we always round up and give a whole number for a percentage. So I hope that's clear. Thanks, girls.